All right, thanks. Very happy to be here. That was a killer panel on registries. There's a very close connection to what we need to, you know, move into this topic of identity and trust. All right, so I've been asked to quickly and give a lightning talk on three acronyms you're seeing on your screen there. Don't worry, I'm going to explain each of them as we move forward, and let's just dive right into it. These are the three projects I'm most involved in right now, and the relevance to I think everything we're talking about today is very strong. Um, okay, I'm trying to move a slow. There, yeah, it's just a little slow in the reaction. Okay, so here are the acronyms: Trust RP, the even though you didn't see it there, Trust RP and DIF, the Decentralized Identity Foundation, are collaborating very closely on these standards. FPP is a first-person project, which I will explain is all about proof of personhood in the age of AI. And it uses a decentralized trust graph, which is why Trust RP and DIF had jointly started in September the Decentralized Trust Graph Working Group. I just came off of another one of our calls every Wednesday about half an hour ago, and that's what I'll be explaining here. So we'll pop over. First, I'm going to cover trust over IP, and as a very high level, this is a lightning talk after all. The TrustRP stack is modeled after the TCP/IP stack. We're 5.5 years into the work at the Linux Foundation project. We're now under LF Decentralized Trust. And as you can see, the four-layer stack is paired with governance because we're talking about the trust layer for the internet, not the internet itself. And so that's been our model. We're now in our third generation of actually doing this diagram. So the whole point of this stack of any and the interoperability we aim to achieve is comes about through having a spanning layer. And for TCP, that spanning layer is the IP protocol you see there, often drawn as an hourglass model. And the whole point with Trust IP was to say we need a similar a very similar four-layer stack. And the second layer is a spanning layer, and the protocol for that we call the trust spanning protocol. Is all about how you just with IP, the TCP/IP stack. We had a new type of address, the IP address that allowed you to connect across different networks with Trust IP, the new form of address, is broadly known as a verifiable identifier. The best known form of verifiable identifiers are W3C DIDs, DIDs. It was a 7-year effort to get that all the way to become a W3C standard, which it became in July of 2022. So the protocols we're talking about at layer two, DIDCOM is the best known today. TSP is coming that they connect DIDs. Now, here's the important thing: because they take care of authenticity and confidentiality and metadata privacy at the trust spanning layer, all of those benefits can be inherited now by protocols that run over that. We are already in the human AI and human trust working group at Trust RP, showing how A2A and MCP can be operated run over TSP. Now, the next protocol I want to talk about is there's a universal demand for trust registries, initially for verifiable credentials. Is this an authorized issuer of the credential? An authorized verifier in some cases. That's what the TRQP protocol is about. That's another task force at Trust RIP. The basic idea of a standard protocol for querying trust registries anywhere. And this shows you how any just like DNS can talk to any name server, TRQP can talk to any trust registry. And it's a very lightweight and efficient protocol just going into its second public review. So that's the basics of what we're doing at Trust RP. Now, first person project, where did this come from? It's all about how do we actually solve proof of personhood in a general and internet standard level way. And so it was all about initially, okay, how do we do this using DIDs and VCs? I'll explain shortly. But also, it quickly became clear that it was also going to solve a second key problem, which was just brought up in the introduction. How can you cryptographically prove a personal AI agent is acting on behalf of a real person and that you control that agent? That agent is delegated. There's a bunch of different, specific delegation credential discussions going on. But what we're about with First Project, how do you actually prove there's a real person behind that? So it was born out of work at all four of these projects at the Linux Foundation. Because it does use DIDs and verifiable credentials, and it involves the protocols and work going on at all four of these organizations. Again, TrustRP is part of LF Decentralized Trust. The good news is the very first customer of the project, the Decentralized Trust Graph, is the Linux Foundation itself. Jim Zemlin gave this keynote address at the LF Member Summit last March to explain that the open source supply chains are having to protect themselves from malware injection attacks and AI agents, and being able to prove the provenance of the code that's now being committed, and that requires this decentralized trust solution. So I don't have time here in this lightning talk to go deeper into how we're doing this. I'm going to talk about decentralized trust graph, but this is the QR code for the white paper we recommend that will give you a full in-depth explanation of the project. And that will be up there long enough for anyone to snap it. What I'll cover is the core concept of why we need a decentralized trust graph and why it needs to be standardized. And again, this slide covers the different parts of that. So the whole origin of First Person Project at the Linux Foundation was, how do we solve proof of personhood without using a global biometric database? And that specifically means without using any kind of or requiring everyone to have a biometric scan of some kind. And there's specific examples on the next slide. So we're trying to avoid the need for this. It's not to say that biometrics cannot be part, and many different what we call trust communities could choose to use them, and those trust communities can be large as what World, for instance, is putting together. But what we wanted to say is, how can we do this in a general way that is an open standard that everyone can build on, and we can have as many trust networks adopting as are necessary. So here we are. The essence of the solution is that we came up with uses DIDs and VCs, and requires two specific new kinds of VCs. They're standard format VCs. They just have a very specific purpose. The first one is called a personhood credential, and it was described in great detail in a wonderful paper that came out last August of a year ago, 2024. And you'll see this has 32 authors from all over the place. I highly recommend this 63-page paper to really understand personhood credentials in depth. The whole thing is the essence of it, I'm summarizing on the next slide, comes down to two requirements. The personal credential issuers must agree to issue one per person. There are many examples of that out there. That's what governments do today, companies do today, universities do today, professional associations. It's just a matter of having them now start to issue personal credentials. The second one is for privacy protection. Those credentials need to use ZKP so that they are unlinkable. That's the same requirement that, for example, the European Digital Identity Wallet community has also decided they're going to need for their digital identity wallets. So with those two credentials, we're adding a second key type of credential, which is called the verifiable relationship credential. And this is what produces the other edges in the decentralized trust graph. And my favorite description of how this works, and the thing that I will wrap up on here, is the analogy that Jim Zemlin used in his keynote address. These verifiable relationship credentials are the modern equivalent of the PGP key signing party, and we're quite serious about that because, and I'm not going to go into the details. These are explained in the first person white paper, but first, the two wallets and agents do a DID credential exchange, and then they issue a verifiable relationship credentials using those two DIDs to each other. And the result is you have a cryptographically verifiable relationship for both parties. If you're interested in all this and you want to help work on the open standards, that's the link to the Decentralized Trust Graph Working Group. Meets every Wednesday, and I'm happy to answer questions about this.